Okay, so this is our second day of angle formulas. Okay, notice these are both sums, sum angle formulas, but they're written a little bit differently than we've written them so far. Okay, so we have this notation that if you've been going to class for any amount of time, you should know. It's called your inverse notation. Okay, so inverse, I hope you have your unit circle handy, because we're going to need to have your unit circle handy as well as a formula chart. Okay, so remember what this means. This is asking us to find the angle where, right? This inverse is asking us to find an angle. So find the angle where the sine equals positive 1/2. Okay, find the angle where the sine equals positive 1/2. So if you go to your unit circle, okay, and you find the y value, we see that that happens at the angle pi over 6. Okay, the angle where the sine is 1/2 is pi over 6. Okay, this is a first quadrant angle. Most of your angles will come from the first quadrant. For cosine, some of them will come from the second quadrant. And if sine is ever negative, it's going to come from the fourth quadrant, but as a negative first quadrant angle. We can talk more about that later. So the second one says, what is the angle where the cosine is 0? So thinking about our unit circle, what is the angle where the cosine is 0? We find that to be the angle pi over 2. So our problem is saying, what is the sine at pi over 6 plus pi over 2? So let's try and figure this out. Well, there's a couple of ways. Let's see if we can just combine these two things first. Okay, notice they don't have the same denominator. So if I really want to add these two fractions together, I could. Actually, let's don't do that. Let's use the formula. Since that's what we're trying to practice, let's practice using the formula. So the sine of a plus b formula is the sine of a times the cosine of b plus the cosine of a times the sine of b. Right? That is the identity for the sine of the sum of two angles. Okay, so that comes right from your formula chart. Hopefully you have your formula chart handy. So the sine, now we're going to replace a with pi over 6. We replace b with pi over 2. So I'm going to color code these. Pi over 2 is b. Plus the cosine of pi over 6, right? That's your A angle, times the sine at pi over 2. Okay, so let's use our formula. That's what we're trying to practice. So rather than going around the formula, let's just use that formula. Okay, so now we go into our unit circle. And we find that the sine at pi over 6 was 1/2. Surprise, surprise. The cosine at pi over 2 is 0. Pretty lovely there. And then the cosine at pi over 6. Well, that's back to our unit circle. The cosine at pi over 6 is root 3 over 2 times the sine at pi over 2, which is 1. So, of course, pi 1/2 times 0, anything times 0 is 0. So then the answer is just root 3 over 2 times 1, which is just root 3 over 2. Okay, and maybe that would have happened up here, right? If this becomes 3 pi over 6, then we're looking at, where is it, 4 pi over 6, which reduces to 2 pi over 3. The sine at 2 pi over 3, sure enough, is root 3 over 2. Okay, but I wanted to practice our formula, right? Because there's a formula for these kind of things. All right, so that's a good one here with number 2. Same kind of deal. You want to find the angle where the sine is positive root 3 over 2, and also the angle where the cosine is 1. Okay, so probably not pi, but 0 is what you're going to use there. So how about we jump down to do number 4? Right, this one is a tricky one, because what do we notice about 3/4? Is 3/4 a unit circle value? And the answer is no, which means we have to draw ourselves a triangle. We're going to draw ourselves a triangle, and this is going to be our angle, right? This is our angle. This is angle A, where the tangent has to be 3/4. So the tangent is a ratio of the opposite side to the adjacent side, which means our opposite side is going to be 3. That's your vertical side, and your adjacent side is going to be 4. Okay, so this is the triangle that we're looking at. This is angle A. This is the triangle where we have a tangent of 3/4. And now we have a separate triangle where the sine is 3/5, right? So this is another triangle. This is another angle. Okay, an angle called B, or beta if you want to call it beta. So this is angle B from a second triangle where the sine is 3/5. So that's once again your opposite side and your hypotenuse. So we know that this is 3 and that's 5. Okay, so if we're looking at finding the tangent, remember the tangent of A plus B only has tan in its formula, right? So this is the formula from your chart of the tan sum. Oh, sorry, that's not what the top looks like. Let me erase that, but let me finish the bottom. Okay, the top looks like tan A plus tan B. Sorry, not 1 plus. Sorry, this is the formula. Tan A plus tan B. So we need to know what is the tangent value at angle B. Okay, do we know what the tangent is from angle B? No, we know the sine, but we can use the Pythagorean theorem in order to find our missing side. And then we can have the tangent ratio, right? Tangent is opposite over adjacent. So it looks like, well, it's going to be the same, right? The tangent here is going to be 3/4. So when we plug this into our formula, right, A is this triangle, so this is triangle A. Your tan value will come from that triangle ratio. And then this is triangle B. Your tan value for B will come from that triangle. Okay, so if we have a non-unit circle angle, we have to draw a right triangle, because these are right triangle trigonometry words. So we can make a right triangle. One is called A, one is called B. And anytime we have sine of A or cosine of A or tan of A, we're looking at the A triangles ratios. Okay, opposite over hypotenuse, adjacent over hypotenuse, and whatnot. Okay, so tangent of A. That's from our A triangle. The tan of A is 3/4. Plus the tan of B. That's from our B triangle, and it's also 3/4. Okay, just so happens that they're the same ratio here because the triangles are the same. Anyway, over 1 minus tan of A, which was once again 3/4, times the tan of B, which is once again 3/4. Okay, so here we have ourselves a lot of fractions, and we're going to have to remember how to do fractions. Sorry, fractions are part of life, and we're going to have to know how to add and subtract them, especially in a math class. So on our numerator, what is 3/4 plus 3/4? 6/4. 3 plus 3 is 6 over the same denominator 4. Right? When we're adding fractions, the denominators have to be the same, and we only add numerators. And then in the denominator, I have multiplication. What is 3/4 times 3/4? 3 times 3 is 9. 4 times 4 is 16. So I'm looking at this 6/4 divided by 1 minus 9/16. Okay? So let's do this. What is 1 minus 9/16? Well, 1, we of course, hopefully, I don't want to say of course, hopefully you know that 1 is also known as 16 divided by 16, because anything divided by itself is 1. So we have to change your 1 into a fraction with the same denominator as the thing you're trying to operate, in this case, subtract. So 16 minus 9 is 7/16. Okay, the tangent ones are the most work because they have things with fractions. So now I have 6/4 divided by 7/16. And if you've listened to any of my videos, we don't divide by fractions, but rather we multiply by the reciprocals. So we take our 7/16 and we reciprocate it to become 16/7. Right? We don't divide by fractions, we multiply by their reciprocals. Okay, so we have on top 6 times 16, and on bottom 7 times 4. Well, let's do a little bit of simplification first, right? I don't want to have to do this in my calculator. I know that 16 divided by 4 is 4, right? 16 divided by 4 is 4. Now we don't have anything else to reduce. 6 times 4 is 24, and 7 times 1 is 7. So the tangent of these two things, whatever it was, a plus b, is going to be 24/7. That is the ratio, aka the answer for our problem. Okay, so once again, if we have a non-unit circle angle, right, this is a ratio that's not on the unit circle, we need to draw a triangle to represent that ratio. Okay, so we draw a triangle. It has an opposite side of 3 and an adjacent side of 4. We have the sine ratio, which is opposite over hypotenuse, and we use Pythagorean to calculate our opposite side because we need to know the tangent ratio from triangle B in order to do a tan sum. Okay, so there's another problem on your assignment, which is this same page, that has that same situation. Part 3, right, we have a cosine of 3/5. So that means there's a triangle out there in the world where this is angle A. The cosine is the adjacent over the hypotenuse. Okay, so that's our 3 triangle there. And then we have a second triangle where the sine is 5/13. Okay, so this is angle B, right? That's 5/13. And we can, of course, use Pythagoras to find your missing values, right? Because sine needs a sine and a cosine from both of your triangles. So we have to have the sine, which is the opposite over the hypotenuse, and the cosine, which is the adjacent over the hypotenuse for both triangles. Okay, so there's a little bit more work to do when we have a non-unit circle value, but it's not impossible. Okay, just have to remember the first week of trigonometry and the ratios that were given. Okay, that's all.